Hey, what is up, everybody? So today I'm going to be attempting this problem called the TwoSum, okay, from Leetcode. So in this problem, let's go through it. We are given an array of integers, nums, and an integer target. We want to return the indices of the two numbers such that they add up to target. And important thing to note is that each input would have exactly one solution, and you may not use the same element twice. Okay, you can return the answer in any order. Okay, this is very important. In any order and exactly one solution. Okay, I'm using Python 3, Python the best framework in the world for interview. Okay, so for example, let's say we have nums equals to 2, 7, 11, 15. Okay, this is our input data. And we know that 2 and 7 add up to our target 9, right? So it will be the index 0 and index 1 equals 9 and return 0 and 1. Okay, this is the easiest solution. Other than that, we have 3, 2, 4, and then we have 2 and 4 adds up to 6. So it will return 1 and 2. Okay, so we have some generic constraints like the length of the array will be at least 2, right? Up to about 10,000 or so. And then the numbers can be negative and the target can be negative as well. Okay, up to a negative 10 billion and positive 10 billion. Okay, and follow up, can we come up with an algorithm with less than ON time complexity? Okay, and we are back. Let's just do the approach one, brute force. You can actually just click on hint here. Brute force way, okay, let's just hint one. A brute force way will be search all the possible pairs of numbers, but that would be too slow. It's best to try out brute force solutions just for completeness, but it's from these brute force solutions that you can come up with optimizations. Okay, so let's just do a loop for the nums. Okay, we can't just loop the object directly. We have to look through the indexes. So I will just put n equals to the length of nums, and we will do for I in n. Okay, we will look through the range. Next up, we will get the current number, which we can just do nums accessed by 1, and we can do for k in range n as well. Okay, I will optimize it later, but I'll just put it this for now. So we know the current number. Let's say the current number is the current will be 2, right? The value will be 2. The index will be 0. Okay, and we want to find out what is the number that we can add to 2 to add up to 9, right? According to this initial test case. Yeah, let me just put target equals 9. Okay, so we want to know what is the complement that we can add up to. So it'll be target minus current, right? So in the inner loop, we want to find okay, so we will get the complement value as 7 in this case, right? So for the next part of the okay, inner loop, we want to loop through the range, right? And when we want to skip if it's I. So if I equals to k, we want to skip this. We can just do a continue. Okay, so it goes to the next leap. Let me just go ahead and pull this down. Okay, so we want to find the index of complement, not just find complement. Okay, if exists, it returns. Okay, so if complement equals to nums k, then we have found the answer. So we can just return I and k, right? You can even do a sorted over here to make it smaller to, okay, bigger, right? Just do a return none outside just for good measure. And let's see. Let's run it. Okay, it says accepted. Okay. And case 2, it returns 1 and 2 as well. So this will be the brute force approach. Database 3301. Okay, so this is the brute force. Okay, so in our previous solution, when you have two for loops like this, it will result in an on square time complexity. And that is usually a very bad solution, right? If you have this in your coding interview, actually you might have already failed the interview. So we don't want to give that as our solution, right? And then we want to look at the inner part. We see this for loop over here, right? We realize that there are going to be cases where you have already traversed the element on the outer loop, but you want to find it again in the inner loop, right? But since the solution says that there's only exactly one solution, and you may return the answer in any order, we can actually just trace the memory of it, okay? And how we do that, we can declare a trace dictionary, right? To trace the value of this current element, okay? So we want to trace it such that we know 2 value 2 is at position 0, okay? It's at index 0, right? So we, so after each loop, right, we check for the complement, right? And then we save this trace value and its index, right? And we want to check whether if complement is in trace, right? If it's in trace, we found the answer. Okay, then we just need to return trace the index of the complement and the current index. And we can also just, okay, so we do complement, check if complement is in trace, and then we can also do if sorted is inside, okay? And then we would not need this inner loop anymore. Okay, so this will just result in a one pass solution. Okay, so let's just run it to see if there are any debugging issues. And it's also good practice to just read through the code yourself and just try to mentally check if your code has any issues, right? So we can see that the test case is passing correctly. Why not just add a custom test case, right? Since we have time for it. Okay. Let's say I want a 7 plus 6 gives me 13. So I'll just put 6 here. Target is 13. And my answer should be 1, index 1 and index 3. Okay. Let's see. Let me run this. Okay, solution either does not exist or is not unique, right? Yeah, so this solution is not unique because 2 plus 11 will give you 13 as well, right? So what I want to do is I change this to 17. Okay, so it will give me one unique solution. So you can see that the question actually makes it very easy for you to actually pass it, right? So that's why this is an Leetcode easy. Okay, so let's just go to test case 4, the one that I wrote. So 7 plus 6 equals to 13. So it'll be index 1 and 3. 1 and 3. Okay, there we go. Okay, if we don't do sorted, right, we will just get the answer as well. Okay, and that will be the end of this solution.